Hello students. We will talk about implicit functions and their derivatives today. Let us see what is an explicit function first of all. Now, a function, as usual in a function, we are going to take two variables. Say one is a dependent variable, usually we take y as a dependent variable, and the other is an independent variable. Usually we take x as an independent variable. Now, in an explicit function, the dependent variable is clearly stated in terms of the independent variable. We usually write it as y is equal to fx. For example, y is equal to x square minus 2x. Here we know the clear relation between x and y. If somebody asked us to find the derivative of such a function, we can easily find it, isn't it? Similarly, these are other examples of explicit functions. In all these examples, you know that you can take y on one side and all the x containing terms on the other side. And clearly you can find their derivatives. If somebody asked you to differentiate these functions as you have done before as well, you can clearly do it in a very easy manner. Think about this particular function. Is it explicit or is it not explicit? Just think about it and decide in your mind. Now in the past, we have used explicit functions. And we have also solved sums regarding explicit functions. It was quite easy to differentiate those functions as you have seen. Here we are going to see what is an implicit function now. In an implicit function, the dependent variable is not clearly expressed in terms of the independent variable. We cannot express y clearly in terms of x. Even though we know that both of them are related. The relationship is clearly seen. In general, we write an implicit function as fxy is equal to 0. We take all the terms on one side so that on the other side we get 0. For example, look at this function x raised to m plus y raised to n is equal to x plus y the whole raised to m plus n. Here we cannot take y on one side and put all the x containing terms only on the other side, isn't it? It is quite difficult to do so. The differentiation of this function also, we cannot do it directly. We have to use other methods for differentiation. This is another example of an implicit function and one more example. In all these examples, as you can see, y cannot be written clearly as a function of x. So in this exercise, we are going to learn how to differentiate implicit functions. We are going to see different categories of sums. The question is same for all categories, that is, find dy by dx. The first question, root x plus root y is equal to root a. Now the first step, we write root y on one side and take the other terms on the other side. That is, root a minus root x comes on the RHS. Now anything, the square root of any term is raised to the power half. So root y is y raised to half. Similarly, root a and root x are also raised to half. Thus we get the next step here. Now we differentiate both the sides with respect to x. So on the LHS, y raised to half, we use the formula y raised to n. That is, the differentiation of x raised to n is n into x raised to n minus 1. So y raised to half becomes half into y raised to half minus 1. And the half minus 1 is minus 1 upon 2. Thus, half y raised to minus 1 upon 2 we get as the differentiation, also into dy by dx. Because you must remember that we are differentiating with respect to x. Therefore, by chain rule, we also have to write dy by dx is equal to, now a raised to half is a constant. Differentiation of any constant is 0. I want to remind you about it. And therefore the term goes away. So the remaining term, that is minus x raised to half, becomes minus half x raised to minus 1 upon 2 by using the same formula, that is x raised to n formula. Then in the next step, as we can see, half is common, so we just cancel it. And therefore now y raised to minus half becomes 1 upon y raised to half. And y raised to half means square root of y. So we get 1 upon root y dy by dx is equal to minus 1 upon root x in the same manner. Thus, dy by dx becomes minus root y upon root x. You can also combine the roots and write it as minus root of y upon x by writing both the terms under a common root. Let us see the next sum now. The next sum, x cube plus y cube plus 4x cube y is equal to 0. Now in this term, as you can see over here, first itself, 4x cube y contains two terms, isn't it? X cube, 4x cube is one term, say, and y is the other term. So you have to use the product rule, remember that. Differentiating both the sides with respect to x, we get, now x cube becomes 3x square. The differentiation of x cube is of course 3x square, as you know by now very well. Y cube becomes 3y square into dy by dx by chain rule. And the last term, we take 4 outside the bracket as common and we use the product rule for x cube into y. So it is x cube dy by dx plus y into 3x square is equal to 0, of course. As you can see, u dv by dx plus v du by dx, that is what we have done for the last term. In the next step, we just simplify the last term by opening the brackets and we get this particular term that is written here. And then the next step, observe the next step. What have we done over here? We have grouped the dy by dx containing terms together. This is going to be a common step for all our sums now. We group together the terms containing dy by dx. So we get 3y square plus 4x cube into dy by dx. And the remaining terms we write them as they are. Now in the next step, the dy by dx containing terms are written on one side. And the remaining terms which do not contain dy by dx are taken to the other side. Again, this is going to be a common step for all the sums. So what have we got over here? We have got dy by dx on one side and the remaining terms you have taken on the other side. We see that in the numerator minus 3x square is common to both the terms. So we just take it outside and the remaining term, that is 1 plus 4y, comes inside the bracket. The denominator remains the same. In the next step, in the next sum, we see that two terms, that is x square y and xy square, both of them contain two parts, isn't it? So we use the product rule for both of them. Thus, we start differentiating both the sides with respect to x and we get x cube becomes 3x square as we saw in the previous part itself. X square y, by using product rule, it becomes x square dy by dx plus y into 2x plus xy square becomes x into 2y dy by dx plus y square into, we remember that d dx of x is 1. So y square into 1, that is y square it remains. And the last term, y cube, becomes 3y square into dy by dx. On the RHS, 81 is a constant, so when we differentiate we get 0. Remember, wherever y comes, after differentiation you also write dy by dx by using chain rule. In the next step, we take all the terms containing dy by dx common inside a bracket. The remaining terms are written as they are. And in the next step, the dy by dx containing terms are written on one side. All the other terms are taken to the other side. Thus, on the RHS, we get minus common 3x square plus 2xy plus y square. Then, dy by dx. For finding dy by dx, we take all the terms on the RHS. Only dy by dx remains on the LHS. And thus, we get our answer. Now, these three sums are similar to the previous sum. You can try them out as assignment. In the next sum, ax square plus 2hxy plus by square is equal to 0. This is one of the MCQs which are given in your miscellaneous exercise in the textbook. So, solving it, that is differentiating, we get ax square becomes 2ax plus 2hxy. So 2h we take common. The remaining xy, we use a product rule for finding the answer. That is x dy by dx plus y plus b is a constant. It is written as it is. Y square becomes 2y dy by dx. Then the same step, that is, we open the middle bracket actually here. We open the middle bracket. We write the two terms. The middle bracket becomes 2h x dy by dx plus 2h into y. And then we group together the terms containing dy by dx. We write the terms containing dy by dx on one side and the remaining terms on the other side. You find that dy by dx can be obtained by taking all the terms on the RHS. Again, since 2 is common in the numerator and denominator, you cancel out 2 and get your final answer. Now this is the answer for the MCQ given in your textbook. And so you realize that MCQs also have to be solved and the answer has to be got. You cannot guess at the answer for MCQs in maths. Now the second category of questions. The first one in that, y into e raised to x plus x into e raised to y is equal to 1. Here, we differentiate both the sides with respect to x. We realize that both the terms we have to use product rule. And so, y into e raised to x, the differentiation of that becomes y into the d dx of e raised to x is e raised to x itself plus e raised to x into the differentiation of y, that is dy by dx. The other term x into e raised to y becomes x into e raised to y dy by dx by chain rule plus e raised to y into d dx of x is 1. On the RHS, of course, differentiation of 1 becomes 0. In the next step, we take the terms containing dy by dx and write them in the bracket. In the next step, the dy by dx terms are put on one side. The remaining terms are written on the RHS. Then we get the final answer for dy by dx by rearranging all the terms on the RHS. In the next question, the question is x raised to y is equal to e raised to x minus y. Without me telling you, you have realized what to do over here, isn't it? We cannot solve further without using logarithms. So, we take logarithm of both sides. Thus, we get log x raised to y, which becomes y log x is equal to x minus y log e. Again, you realize from our previous lecture that the value of log e is 1. Thus, we get y log x is equal to x minus y. And then y log x plus y is equal to x. By taking all the y containing terms on one side in this sum, you get y log x plus y is equal to x. Now you take y common on the LHS. In the bracket, you get log x plus 1. Therefore, y becomes x upon 1 plus log x. Now differentiate both the sides with respect to x. Thus we get dy by dx. Y becomes dy by dx is equal to, on the RHS, you use the quotient rule. That is u upon v rule. So it becomes 1 plus log x, that is the denominator, the differentiation of numerator, minus numerator, the differentiation of denominator, upon the denominator, the whole square. Just see if I have done the same thing over here. So the next step, as you can see from here, the differentiation of x becomes 1. So we get 1 plus log x minus x into the differentiation of 1 plus log x. Well, the differentiation of 1 is 0 and log x becomes 1 upon x. Now x and x gets cancelled. So in the next step, we get 1 plus log x minus 1 upon the denominator remains the same. 1 and minus 1 goes off and we get our final answer for this. In the next sum, xy is equal to log xy. We begin by differentiating both the sides with respect to x. On the LHS, we use the product rule. So we get x into dy by dx plus y into differentiation of x becomes 1 is equal to, on the RHS, log xy, the differentiation of log xy is 1 upon xy into, by chain rule, we also write d dx of xy. In the next step, on the RHS, 1 upon xy into the differentiation of xy becomes x into dy by dx plus y. And then we open the bracket on the RHS. And we get 1 upon xy into x dy by dx plus y into 1 upon xy. As you can see, we cancel the similar terms from the numerator and the denominator. Thus we get on the RHS 1 upon y dy by dx plus 1 upon x. We group the terms containing dy by dx and bring them to one side. And the remaining terms we write on the other side. Thus on the LHS, x minus 1 upon y into dy by dx is equal to 1 upon x minus y. To simplify it further, we cross multiply and equalize the bracket on both the sides. Thus, xy minus 1 upon y dy by dx is equal to 1 minus xy upon x. Observe that cross multiplication has been done. Thus, dy by dx is equal to. Now, xy minus 1 upon y goes on the RHS and becomes y upon xy minus 1. It becomes its reciprocal. And thus we get the final answer like so. Now this sum can be done by you as an assignment in your notebook. It's an activity given on page number 102 of your textbook. You can take the help of the steps which are given there to complete this sum. This sum also can be completed by you as an assignment. In the next sum, next category, that is, the first sum here, if x raised to 5 into y raised to 7 is equal to x plus y raised to 12, then show that dy by dx is equal to y upon x. Now in this sum, we take log of both the sides. So we get log on both, we write log on both the sides and rewrite the sum actually. Now you know that when two numbers are multiplied together, their logarithms can be added. We have learned this rule earlier in an earlier lecture. So we get log x raised to 5 plus log y raised to 7 on the LHS. Then the power of a logarithm can be multiplied to the log and mean the same thing. So log x raised to 5 becomes 5 log x. Similarly, log y raised to 7 we can write it as 7 log y. On the RHS we get 12 log x plus y. Then differentiating both the sides with respect to x, we get 5 into 1 upon x because log the differentiation of 1 is 1 upon. So 5 into 1 upon x plus 7 into 1 upon y dy by dx. Remember the chain rule is equal to 12 1 upon x plus y into again the derivative of x plus y upon dx. Thus 5 upon x plus 7 upon y dy by dx is equal to 12 upon x plus y, and the bracket becomes 1 plus dy by dx because we have found the derivative over here. Then on the RHS we open the brackets, we multiply 12 upon x plus y to both the terms, and then we bring the dy by dx terms on the LHS. The remaining terms we write on the RHS. We take dy by dx common on the LHS. And in the next step, see carefully, we have cross multiplied and made the denominators equal. So thus we get this particular term on the LHS as well as on the RHS. Look at it very carefully. Thus we get the next step here by solving the brackets on the LHS and the RHS. We cancel the common terms. And we get 1 upon y dy by dx is equal to 1 upon x. Thus dy by dx becomes y upon x. Now the next sum. If you see the next sum and compare it with the previous one, you will find that both of the sums are similar. So you can observe the steps which are very much same for this sum as well. Just pause the video wherever and observe what has been done for this sum. You will find that it is exactly the same as the previous one. So thus you get the answer for this sum as well. Now these two sums can be done in a similar manner as an assignment by you. The third sum is just the same as the first one, and the fourth one you can do just like the second one. Now look at this sum. The question is, if x raised to 4 into y raised to 5 is equal to x plus y raised to m plus 1. Also, dy by dx is equal to y upon x. Then what is the value of m? It's an MCQ question, obviously. Now, by doing these sums, you will realize that on the LHS, the sum of the power of the terms will be the same as the power of the term on the RHS. That means 4 plus 5 on the LHS, the powers, will become 9 on the RHS. Thus, m plus 1 will become 8 plus 1. So, the value of m will become 8. In the next sum, log x plus y is equal to log xy plus a. So, show that dy by dx is equal to minus y square upon x square. So, we start by differentiating both the sides with respect to x. Thus, LHS becomes 1 upon x plus y into d dx of x plus y is equal to RHS. Log xy becomes 1 upon xy d dx of xy. A is a constant, so it becomes 0. Thus, on the LHS, 1 upon xy, the derivative of x plus y is 1 plus dy by dx is equal to, on the RHS, 1 upon xy into the derivative of xy. Obviously, we use a product rule and get the answer here for the bracket. And then we open the brackets on both the sides and thus write the terms like so. We cancel out the x on the RHS and the y also, and thus we get on the RHS, LHS remains the same. RHS 1 upon y dy by dx plus 1 upon x. Now we take the dy by dx containing terms on the LHS. The remaining terms are written on the RHS. Then we simplify one step further and then we equalize the denominators by cross multiplication. And then by simplifying, we get x upon y dy by dx is equal to y upon x. Thus, dy by dx becomes minus y square upon x square. In the next sum, if e raised to x plus e raised to y is equal to e raised to x plus y, then we have to show that dy by dx is equal to minus e raised to y minus x. Now remember the first equation. It is e raised to x plus e raised to y is equal to e raised to x plus y. Differentiating both the sides, the differentiation of e raised to x is e raised to x. E raised to y becomes e raised to y dy by dx. And on the RHS, e raised to x plus y is e raised to x plus y into differentiation of x plus y as well. In the next step, on the RHS, the differentiation of x plus y 1 plus dy by dx. Then in the next step, on the RHS, the bracket is open. It is multiplied with e raised to x plus y. Then the dy by dx containing terms are brought together on the LHS. The remaining terms are written on the RHS. Then we simplify and get what is dy by dx. But then they have told us that dy by dx is minus e raised to y minus x. So for this, we write the first equation, that is from the first equation. We know that e raised to x plus e raised to y is equal to e raised to x plus y. So we substitute e raised to x plus y term in the dy by dx. Like so, that is instead of e raised to x plus y, we write e raised to x plus e raised to y in the numerator as well as in the denominator. We cancel out the similar terms in the numerator and the denominator, and thus we get dy by dx is equal to e raised to y upon minus e raised to x. Then we simplify further. When we bring e raised to x term to the numerator, we are going to get e raised to minus x. And you know that when two terms are multiplied together, their powers can be added. Thus we get minus e raised to y minus x. This becomes our answer here. A similar sum which you can do as assignment in your notebook. I have written the answer in the bracket for your reference. In the next sum, if x cube y cube is equal to x square minus y square, find dy by dx. Here, we start by differentiating both the sides with respect to x. On the LHS, we use the product rule. So, we get x cube into 3y square dy by dx plus y cube into 3x square. On the RHS, x square becomes 2x and y square becomes 2y dy by dx. We write the dy by dx containing terms on one side, the remaining terms on the other side. We simplify by doing like this, and then we find the final answer, that is dy by dx. We can take x common and y common in the numerator and the denominator respectively and get our final answer. These two sums can be done by you as an assignment. I have written the answers in the bracket for reference. With this, we complete all the sums regarding implicit functions. I have tried to include all the sums which are there in your exercise as well as in your miscellaneous exercise. Sincerely do the sums which are given as assignment, because practice is going to make you perfect. In the next lecture, we meet with the next concept. Stay safe and healthy.